start streaming, so I'm going to do that now.
That's your job to remind everyone. You haven't done a single thing. Don't throw shit at me.
Yeah, I would have said creek. Now, you need enough energy, but if you collide, what else do you need? Yeah?
Correct orientation.
Correct orientation. Have you done this before?
Yes.
Okay. I'm going to stop calling on you. About 1 second before your question.
James, you're a genius.
So they also need geometry. So if you go on a date and you don't know which end is up, no successful collisions.
Wait, what?
And of course, by that I mean, if you're sitting down to have a meal with them and you're both facing the opposite directions, nothing's really going to happen. Now, there was a question over here. Well, no, I didn't hear a bell.
It's 45.
The class ends at 50 because the alternate schedule.
Yeah.
What the hell?
Class ends at 11:50. I still got 5 more minutes. Don't bother me. Okay, question.
Is it like orientation only for complex molecules?
No.
Well, I read it somewhere online though that it says it's only like significant.
Do you believe everything you read online?
Yes.
Yeah.
No.
Obviously. Why wouldn't you?
I found it on like
TikTok is the
one
only
of
news
the
source I have.
chemistry
No.
websites.
No.
I get all my news from.
I know I said the word dating at one point, and that's kind of funny, but we need to also pay attention and allow people to ask questions. The reason why they might have said that, I'm going to try and guess, is that the simpler the reaction, the less precise the orientation has to be. Because if they just have to hit each other, and they're just a couple of molecules, there's probably a lot of configurations they can hit, and you'll still get a reaction. But you still need the right geometry. If they hit themselves in the exact wrong way, they're just going to bounce back off. They're not going to do anything. An enzyme ensures very precise geometry for very complex reactions. But most reactions still only have 2 particles. No collision ever has really more than 2. Reactions that require 3 particles to hit at the same time just basically don't occur. So most collision theory is just based on 2 particles hitting. The more complex the reaction or the more precise it has to hit, you got to have, the more likely you need an enzyme or a catalyst or something to get it to happen at all. And those work by presenting them in a particular way. But I would not say, personally, that it never needs correct geometry. That seems like an overstatement in whatever resource you're using. And I would find that chemist and argue with them. Yes?
Sorry. When you have 3 different reactants coming together, they all have to collide at the same time?
No. What usually that means is that you have a multi-step reaction. It's 2 at a time, 2 at a time, 2 at a time, all the way down. If we want to increase the rate of reaction, then what do we need in terms of collisions? More of them. Frequency, more often. We are going to talk about energy changes. When we talk about energy in molecules, where is that energy located? It's not in the nucleus. It's the nucleus. No, it kind of. What are the electrons in? In. No.
Rotation.
I mean, yes, but no. Where's the energy? If you have a molecule, where's the energy? It's not in some random electron. Very specific. Pardon? They are valence electrons. I mean, these are all wildly close. No.
We don't know the answer clearly.
If you are, how many of you are in biology? Okay, so you know about ATP?
Yeah.
Okay, high energy molecules is adenosine triphosphate, phosphorus. Where's the energy?
The bonds.
When they bond, it's in the bonds.
James Bond. Oh my goodness. How could you not see that?
So all of the energy is locked into bonds. And ATP is our energy molecule. That's how we move molecules around. Reformed, yeah. Because we're going to have a reaction where something breaks, and then it makes something new because you have your reactants; those bonds have to break. Then you have your products; those bonds have to form. Yes.
It's more like a decomposition reaction. Will there still be things, like, will there still be bonds reformed?
Probably. I mean, you could be getting off single ions, in which case they're probably becoming neutral at the very least. But even in a combustion reaction, you're getting off CO2 and water, and those are new bonds. Yeah. Kinetic energy is the energy of motion. And now you're done. Because of the assembly, we're a little bit behind. We're going to go so fast next day.